I want to start today with a bit of an insult, or at least it kind of feels like one to me.
Oh, go on.
There's this theory, it comes from the world of semiotics, the study of signs and symbols.
Right.
And it claims that a video game, or even a classic novel like Moby Dick, is actually a lazy mechanism.
It does sound harsh when you
Yeah.
put it that way.
Yeah.
I mean, you imagine these authors and developers sweating over their keyboards for years,
Yeah.
only to be told their creation is lazy.
Yeah.
But in the context of the research we're covering today, specifically Chapter 8 of Julian Alvarez's work, it's a technically accurate description.
Technically accurate, maybe, but emotionally damaging. But okay, let's get into why. The idea is that the object itself, the code on the disk, the words on the page, is completely static.
An engine without gas.
Exactly. It doesn't actually work until a user shows up to pour their own energy into it.
And that right there is the pivot point for this entire deep dive. We're shifting our focus away from the machine. We've done deep dives on haptics, on VR rendering, on the toys. Today, we are looking exclusively at the fuel. We're looking at the player.
Specifically, we're looking at the massive headache involved in designing a serious game. A game meant to teach or train, when you have absolutely no idea who's going to play it.
That is the fundamental paradox of design, isn't it? You're building a glove, but you've never seen the hand that's going to wear it.
So how do you make sure the glove fits?
You have to build a model.
So we're cracking open Chapter 8, which is all about this modeling process. And it starts with that lazy mechanism concept, which actually comes from Umberto Eco, right? The name of the rose guy.
The very same. And Eco wasn't talking about Mario or Fortnite. He was talking about literature.
Okay.
He described a text as a lazy mechanism because it is full of holes. He calls them interstices.
Interstices. That's a fancy word for gaps.
Essentially, yeah.
Yeah.
If I read a sentence like, the detective walked into the smoky bar, I'm leaving out a massive amount of data. I don't tell you what the floor looks like. I don't tell you if it smells like stale beer or cheap perfume. I don't tell you if the detective is wearing a hat.
I just fill all that in myself.
You do.
Yeah.
I rely on you, the reader, to fill in those blanks using your own cultural database. The author is basically outsourcing the rendering to your brain.
Right.
Eco called this the model reader. An author writes for a hypothetical person who shares enough cultural background to fill in those gaps correctly.
And if you don't know what a bar is, or if you've never seen a detective movie, the mechanism breaks.
The whole thing falls apart. You can't visualize the scene.
Okay, so in a book, the gap is imagination. But the source material for today argues that in games, this gets translated by researchers like Stefan Genbo into the model player.
It does.
But a game isn't just about filling in blanks in a story, it's functional. I have to actually do things.
It's strategic. That's the key difference. Genvo argues that designing a game is a strategy of anticipation.
You're playing a chess match against a ghost.
Exactly.
Yeah.
You have to imagine a fabled player, someone who doesn't exist yet, and predict exactly what they will do when they encounter a locked door.
And if you predict wrong, the game is broken. This reminds me of that yellow paint debate that happens in gaming circles all the time. You've seen this.
Oh, I have. It's where game environments have splashes of bright yellow paint on every ledge you can climb or every box you can break.
Right, and players complain, why are you treating me like an idiot? I know I can climb that. But based on this theory that yellow paint exists because the designer's model player failed.
There's a patch. The designer originally anticipated a model player with, high observation skills who would notice the ledge naturally.
But then people actually played it.
And they play tested it, realized real humans aren't that observant, and the game just ground to a halt. The lazy mechanism stopped moving.
So they grabbed the yellow paint.
They realized the actual player had a lower competence than the model they'd built.
Which brings us to a really critical distinction in the text.
It does.
In English conversation, we tend to use the words interactivity and playability interchangeably. But in the French research, this concept of jouabilité, they are two totally different loops.
Completely different.
So walk me through the interactivity loop first.
Interactivity is the machine loop. It's a very functional relationship between hardware and software.
Input, output.
Exactly. You press the A button, the character on screen jumps. It's binary, it works, or it's broken.
Okay, so if my controller isn't unplugged and the code isn't buggy, the interactivity is fine.
Correct. But playability is the human loop. It happens entirely outside the computer.
What do you mean?
It's the player looking at the screen, interpreting the image, feeling an emotion, maybe stress, maybe curiosity, maybe confusion, and then deciding to press A.
So interactivity is the gun fires. Playability is, do I want to fire the gun?
Yeah.
And do I know why I'm firing it?
That is where the magic and the difficulty lies. The machine is blind to the playability loop. It doesn't know you're hesitating. It doesn't know you're smiling.
It just waits for the input.
And for that input to make sense, the player needs what the source calls ludic competence.
Ludic, meaning game-related.
Yes, and the source uses this great example from researchers Perron and Arsenal involving a crowbar.
I loved this detail because it just highlights how weird gamer brain actually is.
It really does. So imagine a scene. You're in a hallway. There's a boarded up door, and there is a crowbar lying on the floor.
Okay.
Now, in the real world, if you handed a crowbar to a carpenter or a firefighter, they know exactly what to do.
Yeah, it's a tool. It's physics. You pry the wood.
But in a video game, a crowbar isn't necessarily a tool.
No. In one game, a crowbar might be a weapon for hitting zombies, and it won't work on doors at all.
Or in another game, it might just be background texture. A picture of a crowbar you can't even pick up.
And in a third game, you might need to combine it with a hammer in some crafting menu.
Right. So knowing what to do isn't about real-world logic. It's about game logic. It's about having a vocabulary of past experiences. The source references John Dewey here. This idea that experience is cumulative. If you hand a controller to your grandmother who has never played Half-Life,
Right.
she sees a crowbar and thinks tool. She tries to use it. Nothing happens. She gets frustrated.
She lacks the ludic competence to know that in this specific genre, crowbars are for hitting aliens, not opening doors.
She is not the model player the designer built the game for. And that's the danger for serious games.
How so?
Well, if I'm building a safety training simulation for a factory, and I design it with gamer logic, expecting players to know a red barrel explodes if you shoot it. But the 50-year-old floor manager has never played Doom. The training just fails.
And it fails in a really specific way. It's not that the floor manager is stupid. It's that the playability gap is too wide. The designer modeled the wrong human.
That is the #1 reason corporate gamification fails.
Right.
You're asking someone to speak a language they never learned.
So we have to look at who these players actually are. We can't just say the user. We have to profile them.
We have to categorize the humans.
Now, I think most people who've dabbled in this stuff know Bartle's taxonomy, the 4 types. Killers, achievers, socializers, explorers.
It's the horoscope of game design.
It really is.
Yeah.
I'm a Sagittarius, so I'm an explorer.
Right. And it's a classic model, but the source actually points out that it's a bit outdated, or maybe just too rigid. The text argues that we are plural.
Plural. You mean we change types?
Think about your own habits. You might be a killer when you play a competitive shooter, aggressive, trash-talking, wanting to dominate the leaderboard.
Sure.
But then you log off, open up Animal Crossing or some farming simulator, and suddenly you're a socializer, sending gifts to your neighbors and watering their plants.
I feel called out. But yes, absolutely, the context dictates the profile.
So for a designer, you can't just say target audience, achievers. You have to ask, in this specific learning module, what behavior are we trying to trigger?
And that's where the source shifts to Andrzej Marczewski's model.
Yeah, which is much more nuanced for gamification. And he introduces a type that I think every corporate trainer has nightmares about, the disruptor.
The disruptor. This is the person who isn't trying to win and isn't trying to lose. They're just trying to burn it all down.
They want to test the boundaries. What happens if I click this button 500 times? Can I walk through this wall? Can I cheat the quiz by inspecting the HTML code?
In a regular game, those people are beta testers. In a serious game for a company, those people are a liability.
Or an asset, if you design for them. But Marczewski also makes this crucial split regarding motivation. Intrinsic versus extrinsic.
Okay, what's the difference?
Intrinsic is I play because I want to master this skill. Extrinsic is I play because I want the badge or the gift card.
And mixing these people is dangerous. The source warns about the conflict between the philanthropist and the self-seeker.
This is such a fascinating dynamic. Imagine a collaborative learning game for a sales team. The philanthropists are motivated by purpose. They want to help the whole team succeed.
And the self-seekers?
They're motivated by rewards. They just want to maximize their own score.
I can see where this is going.
If you put them in the same group without the right rules, the self-seekers will absolutely exploit the philanthropists. They'll let the helpers do all the work, and then they'll swoop in to steal the points of the credit.
And then the philanthropists realize they're being used, so they just quit, and the entire ecosystem collapses.
Exactly. The lazy mechanism stops working because the social engine broke. So to avoid that, you have to understand the deep psychological drives that keep people engaged.
And this brings us to the octalysis framework by Yu-Kai Cho.
This is probably the densest part of the chapter, but it's so critical.
It's an octagon of 8 core drives. We won't list them all, but I want to focus on the tension the source highlights.
Right.
The difference between white hat and black hat gamification. Because black hat sounds, well, it sounds like hacking.
It sounds villainous. But in this context, it just refers to the nature of the motivation. White hat drives are things like meaning, empowerment, social influence.
They make you feel good. They make you feel in control.
Yes. And black hat drives are scarcity, unpredictability, and avoidance.
Scarcity is only 2 seats left at this price. Unpredictability is the slot machine logic. And avoidance is the app telling me, I'm going to lose my 200-day streak if I don't log in right now.
Avoidance is a massive driver. We hate losing things more than we like gaining things. But here's the catch.
Okay.
Black hat techniques are incredibly effective at driving short-term action. If you want someone to log in today, threaten their streak, scare them a little.
But I'm assuming there's a cost to scaring your users.
The source notes that long-term, black hat creates burnout. It feels manipulative. It feels like a job.
Right.
And we're talking about learning, real deep learning. You can't sustain that on anxiety. You can't learn algebra just because you're afraid of losing a badge.
Eventually, you just resent the badge.
You do. You need the white hat stuff. You need epic meaning. You need to feel like you are doing this for a real reason.
Which transitions us perfectly to the final piece of this puzzle. How do we map all this, the profiles, the drives, the playability, onto actual education?
Because that's the goal, right? We aren't just making games for fun. We're making serious games.
Exactly.
The source uses Roland Vio's model of student motivation. And this, for me, was the light bulb moment reading this chapter.
How so?
It's essentially a translation layer between game design and pedagogy.
So Viao lists conditions for a student to be motivated. Things like perception of value, perception of competence, and the text just maps these directly to game mechanics.
Let's look at control. Viao says a student needs to feel they have agency. If they're just following instructions, they disengage.
And a game is pure agency.
It's a series of interesting choices. If you strip away the choice, it's not a game anymore, it's a lecture.
Then there's challenge. Vio calls it the défi. It can't be too hard, can't be too easy.
That is literally the definition of flow in game theory. But the biggest one for me is feedback. In a traditional classroom, the feedback loop is incredibly slow. You write an essay, you hand it in, you wait a week, you get a grade.
And by the time I get the paper back, I don't even remember writing it. I've moved on.
Exactly. The connection between action and result is broken by time. But in a game, you jump too early, you fall into the pit. Immediate feedback.
You adjust, you try again.
The source argues that games are actually structurally superior to traditional schooling for this specific condition. They allow for what it calls iterative failure.
Iterative failure. That sounds much better than getting an F.
Doesn't it? It implies that failing is part of the process of learning, not the end of it. It turns failure into data.
When you die in Mario, you don't think, I'm a failure. You think, okay, I need to jump half a second later.
You're learning the system. Vio's condition of competence is met because you feel yourself getting better. In school, you often just feel like you're surviving this semester.
So, if we step back and look at Chapter 8 as a whole, we're seeing this shift in how we talk about these tools. Serious games used to be about how do we make the graphics look good?
Or how do we simulate the physics of a forklift?
And now the question is, how do we simulate the user's brain? It's moving from engineering to empathy.
Strategic empathy. You have to build a system that aligns with the drives of a disruptor, an achiever, and a socializer all at once, while balancing anxiety and satisfaction to create a state where learning happens naturally.
It makes the job of a game designer sound almost impossible. You're a psychologist, a teacher, and a coder all wrapped in one.
It is a high bar. But when it works, when the model fits the player, you get that surplus of meaning.
The lazy mechanism stops being lazy. It wakes up.
Precisely.
I want to leave the listener with a thought that struck me while reading about the black hat drives, the scarcity and avoidance. We rely on these mechanisms to keep people engaged in learning apps, the don't break your streak notifications.
We do. It's the industry standard because it works. It drives metrics.
But there's a functional question there, isn't there? If I'm designing a game to teach you ethics or leadership or some complex skill, but I'm using anxiety-inducing manipulation to keep you playing, Is that actually effective?
It's the dark side of the model player.
Yeah.
If your model relies on triggering anxiety to get a result, you might get the user to click the button, but you haven't necessarily gotten them to learn the concept.
You've hacked their behavior, not improved their mind.
Right.
Are we playing the game, or is the game playing us? That seems to be the question designers really need to ask themselves.
It is. If the mechanism is lazy, you have to be very careful what kind of fuel you use to wake it up.
But listen to think about next time you're grinding for points. Thanks for diving deep with us today.
Always a pleasure.